Hello everybody, I'm Nick, and in this video I'm going to talk to you about TDD, also known as test-driven development. We're going to talk about what TDD is, why we want to use TDD, and how we can use TDD. I'm going to show you an example explaining exactly what it is, how it works, and what steps you need to follow. First, let's just answer a few questions. What is TDD? Well, test-driven development is a development lifecycle in which you write your tests before you actually write your implementation. First, you have the red mode, and this red mode says write a failing test. This test, it's written in a way that says what your code should be doing. So what a piece of behavior or a piece of software or a unit in your code should be doing. Then next, you make this test pass and you write the minimum amount of code to make this red test a green test. The next thing you need to do is the blue state, and the blue state is the refactor state. During refactoring, you will be modifying the code you wrote at the green step to make your test pass, and you're gonna make it a bit nicer. This is of course only when applicable. And then we go back to the fail test and we write a new test, and then we make this new test pass again. And the cycle goes on and on and on until our software is complete. Doing this, we achieve several things. The major thing you achieve is you eradicate fear of change. TDD eradicates fear of change because these tests are always true. They are your source of truth, and no matter what happens to your code, if the business logic is still sound, these should all pass. If one of them fails, then something happened there, you accidentally had a knock-on effect to another piece of your software, and you go back and change it. This makes refactoring way easier because you can just go to your code, change it, and if a test fails, you know what failed and you know what you broke. This might look like something that makes you write more code to achieve the same thing, but in the long run is way more beneficial. And we will see how you can get into it and how simple it is using a kata as an example. A code kata is an exercise in programming which helps programmers exercise their skills through practice and repetition. There are many katas, but I'm gonna go with the most straightforward one, and this is the string calculator kata. In here, as you can see at your screen right now, I have a solution in C#. By the way, this example is applicable to any programming language. The only thing that changes is the code that you're gonna write and how you're actually going to write your tests. But if you're writing JavaScript or Java or Kotlin or C++ or anything, the approach and the thought process is the same. So if you don't write the same language as me, don't worry, I guarantee you there's a framework to write unit tests in this very same way, and you can use it to achieve the same thing as what you're gonna see now. The first thing I wanna do is I wanna create a text file, and I'm gonna name that string calculator.txt, and in here I'm gonna copy my kata step by step. The string calculator kata is a very simple kata, and the first step says the following. We're going to create a simple calculator that accepts a string, which this string is represented by numbers and a comma separator, and we separate on the comma and we just add the two numbers. So empty string returns 0, 1 returns 1, 1, 2 returns 3, and so on and so forth. This design will drive our TDD approach. So what I'm going to do now is I'm going to create a new project in my solution, and this will be a unit test project using xUnit. In your scenario, it might be NUnit, it might be a different language, but please stick with this to understand the approach. I'm going to name this string calculator.test, so I'm creating that project now. And what I need to do is delete this unit test default class and add a reference to my string calculator project. Now, the requirements are simple. I need to have something that accepts a comma separated or a non-comma separated number containing string and does some math. The first thing I'm going to do is I'm going to create a class called calculator tests. As you can see, I did not create any calculator class to start adding logic. I start from my tests. In here, I have configured my IDE to run unit tests every time I save my document. So as I'll be developing, I will be getting instant feedback of my unit tests. I want to add another package here because I'm going to need it for assertions, and this package is called Fluent Assertions. I will explain what this does as I'm writing the test. Now with the package added, I'm ready to write my first test case. So in C#, I will need to create a theory, and the theory has some inline data, which I'm going to populate in a bit. But first I'm going to write the body. So it's a public void, and I'll be calling the method add when I create it. And all I'm trying to say is let's just read what the document says. Accept string empty, one value or a comma separated set of numbers and add them. So add adds up to 2 numbers, because it does specify that this is for up to 2 numbers separated by commas, and return their sums. So add returns up to 2 numbers when string is valid. And we're only testing for the good scenarios here, for the valid scenarios. First, I want to break down my test in 3 sections, and these sections will be arrange, act, and assert. This is not necessarily part of TDD, but it gives us a clear definition of what each step is doing. And the first thing I want to do is I'm going to have a system under test. I'm going to arrange my calculator class. So I'm going to say new calculator class that does not exist yet. Then what I'm going to do is I'm going to say result equals to system under test dot add, because there will be an add method here. And last but not least, I'm going to say result dot should. This is coming from Fluent Assertions. Let me just make this smaller. B, and there should be some expected value that I'll be comparing it against. And I'm using inline data because I want to test different test cases with the same test body. So what I'm going to say is, here's a string called calculation, and let me make this smaller. And this is the string we will be testing against, and int expected is the text I'm expecting. So I misspelled that here. So I meant to say this is the number I'm expecting. So the sum of these numbers should be adding up to this expected. An example would be string empty should return 0. 1 should return 1. And 1, 2 should return 3. This is according to the requirements in this step. Now that we have this, we clearly don't have the calculator class, so we cannot actually run our test. So we know we need the calculator class because we designed the system based on the test. So I'm going to go to the string calculator project, and I'm going to say create a class called calculator. This is now created, and you can see that now the error is in the add method. I'm going to be copying the calculation and adding it here. And now I can just say to resharper, which is the ID I'm using, create method calculator add. And this method returns an integer. And this is the calculation. I'm going to use the word numbers because I think that's what the test tells me to. Yeah, that's correct. Numbers. And now I'm going to implement the method. I'm going to split this string. So split numbers are the numbers split on a comma. And now what I should say is that if split numbers don't have anything split here, then I'm going to return 0. If split numbers dot length equals 1, which means we have one number or nothing in here, then I'm going to check if split numbers 0 dot length equals 0, which means that the value is this one, string empty, then I'm going to return 0. We're currently in the writing the code to pass the test phase. If that's not the case, then return int.pass, and we are going to pass this single number and return it. And last but not least, we're going to say return, and we are going to return an addition of the 2 split strings. So it looks like this code should satisfy the needs for these tests. Now we need to import something here, but once we've done this, we are able to run our test for the first time. And after that, they should be automatically running every time I save, if I just turn auto saving on. So my test failed, meaning I don't satisfy the criteria. And the problem is that the index is outside of the boundaries. We can see why. As you can see here, is because of a typo which I made accidentally, or you might have made accidentally while you're developing it. And now that I can fix it, I can say that my code will in fact be passing. See, we just got an issue just for pure carelessness without even knowing that we had an issue just because we had a test, which is awesome. So now we have this code that satisfies this test case. Let's make our code a little bit better. You see, I don't think that this is a nice way of writing code, because we could actually use the split options to remove any empty entries automatically on the split level. So what I could say here is I could say, if I just said new char array and I put my delimiter here, I could then say split option remove empty entries. And if I do that, I don't need to check for that or that. And I can just say, if the length is 1, then return 1. If the length is more, then compare the first and the second. I did make a mistake here, and the test caught it, of course. If I just remove the previous version, I automatically lose the 0 check. But if I just say length equals to 0 now, or just change this to any, or it doesn't have any values, and if I run the tests, they're all passing. So we refactor a little bit our code, and that means we can move to the next criteria. So the next thing we need to add, and let me just copy it over, is we need to be able to allow the method to handle an unknown amount of numbers. So I'm gonna copy this and I'm gonna create a new method here. I could in fact add more inline data here. The tests would look identical, at least the body of them, but I want to give different names to specify what I'm testing every time. So now I want to be able to allow any amount of numbers to be added. So if I copy the theory into the inline data, what my test will be looking like is adds up to any number when string is valid. So I'm going to test 1, 2, 3, and this should be adding to 6. And I'll probably add another scenario where it's like 10, and then 90, and then 10 again, and then 20. And this adds up to 130. So if I save this now, let's see what happens. Oh look, the new added tests fail, and that's because we don't have anything to cover them. Now is when we go to the calculator class and we change this. So let's look what we have here. Another requirement is any number can be added. So what if I just remove all that and I say you go to a new line, and now that everything is split, I can actually do a select and pass everything as an integer. And if everything is passed as an integer, link, which is a C# feature, allows us to do the following. We can do split numbers dot sum. And this will summarize any amount of numbers passed as integers separated by the comma, removing all the empty ones, which anyway meant 0 to begin with. So let's see what we did. In fact, all our tests are satisfied, and this new scenario is also satisfied. So there's nothing really we can refactor at this point. So the refactoring step is not applicable. We just made the test pass with a minimum amount of code, and we refactored our code as we went. The next thing we need to add is the following. Let me just copy it over. We need to allow the add method to handle new lines between numbers instead of commas. The new line is another character, and we need to allow for it to be here. We do not need to prove that comma and new line need to be next to each other, and that's not a valid case. So the test specifies us to say that new line is treated just like a comma. Let's go ahead and add the test that actually tests for that. So if I just copy the same thing again, now I say adds numbers using new line delimiter. And let's reuse this. We want to say that this should still give the same result, and then a combination of the two again. should also give the same result. So this is how our test looks like. If I just save and run the tests, they should fail. And in fact, they do fail. So now let's go to the calculator and make it pass. As you can see here in the split method, we're accepting an array of different characters that can actually make our test pass. So I can actually simply go here and say, accept new line as well. And if I save here, they should actually make my test pass. So I satisfied this again. And there's not much refactoring I can do here, but there is a little bit that I can do from what I can see. And this is extracting this array of delimiters into their own variable. So I can say var delimiters equals this array, and then I can copy this here. It gives me more clarity to where I'm splitting on. So with that out of the way, let's move on to the next requirement. And the next requirement is the following. Support different delimiters. To change and delimiter, the beginning of the string will contain a separate line that looks like this. So we have 2 backslashes, and then the delimiter, and then a new line, and then the numbers. So for example, this should return 3. So let's go ahead and write a test to cover that. And I'm just gonna copy this suggested test case, and I'm gonna leave it as a comment here until I paste the test. So let me just do that. So here we go, add adds number using custom delimiter. And I'm gonna use this very test case I talked about, and I'm gonna paste it here. And this should add to 3. And I can actually add another one as well that tests 4 more. So 4 in this scenario, and this adds up to 7. So I have my new test. Let me just save my file, run the test, see what happens. It is failing, so I am going to write some code to add the custom delimiter. Now, to add things to an array, you can, but in this scenario it would be weird to do it. So I can just simply change this to a list, and that's a list of characters. And then I can do the following. I can say, if my numbers start with //, then I'm gonna split on first new line symbol, which is what we're testing for to get our custom delimiter. Now, I can do this by doing numbers dot split, and I'm going to use a new line delimiter here, and I'm gonna say split this up to 2. And the reason why I'm doing that is because I want to split on the first new line appearance. If new line appears on anywhere else in my string, I don't want to split again on that. So this will give me 2 pieces, the first and the second. And then I can just isolate the custom delimiter, and I can say split on new line, get the first part, replace the // with a string.empty, and then just get a single character out of this, because it should be a single character. And then I can do delimiters.add, and I'm going to add the custom delimiter in my arsenal of other delimiters here, and then simply mutate the incoming string from numbers to split on first line second half, which is where I want to run my calculations on. The reason why this is failing is because this needs to be an array, so I'm going to cast it to an array and I'm going to save. And let's see what happens now. All my tests are passing, so this again is now satisfied. I'm going to add another one, and that's going to be the last case that I will be showing you how to do. And you will take 4 more to do on your own. You can find the code for this in the description. You can click on that, fork the project on GitHub, and finish it. So let's read what this is telling us to do. Calling add with a negative number will throw an exception, negative is not allowed, and the negative that was passed. If there are multiple negatives, show all of them in the exception message. Let's go ahead and write a failing test for that, because I think tests that check that something is thrown are very important as well. So what I want to do is, let's see how much we can copy from this. I'm gonna rename this. So let's see what we're testing for. We're testing that add should throw an exception when negative numbers are used in the string. But the arguments are not calculation and expected, but more like calculation and negative numbers. So the calculation, and let's just take it back a little bit, it should look like this: 1, 2, -3. And the expected thing that I want to see failing is this. The -1 is a negative, I want it to fail. And I'm gonna reuse the previous scenario, so this custom delimiter one, and I'm gonna say -2 and -4. And the string I'm gonna test to see what's negative is -2, -4. Now, how do we test that something throws? In C#, using fluent assertions, you can do the following. You can say action, and then you can turn this call into an action, which is a delegate essentially. And what this allows you to do is to say, let me just rename this to action. And this allows me to say, action should throw exception, and I want this exception to have a message specific because the test tells us to. Negatives not allowed. And then I want to say what negatives are not allowed. So negative numbers go here. I'll just break it in a new line so you can see it. So this is what I'm asserting for now. Now clearly this test will now fail, but we're gonna make it pass. Let's go back to our code. Let's see what we have here. So we're past the initial custom delimiter splitting, and we have the split numbers are integers. Remember, negative integers are still integers. So I can just simply go here and say var negative numbers equals new list of integers. And then for each split numbers, which is potentially negative number, I can simply say if potential negative number is less than 0, so it's negative, add it to the negative numbers list. And then after this, I can add the check that says if negative numbers have any values in them, so if we have more than one essentially, then throw new exception, and this exception will read negatives not allowed with what is not allowed, and this will be string.join, and we're gonna say join the following things with a comma, and the things we want to join are the negative numbers. So if I now save that, all my tests are in fact passing because the negative numbers are being thrown. So again, we went from red to green, and now let's go back to blue and refactor. And how can we refactor this? Well, there are many ways. I don't like the fact that we're using a for each loop. We can just change this. So we can say negative numbers equals split numbers dot where, using link, x is less than 0. And we're going to enumerate that to a list. And these are all the negative numbers. So if we have any negative numbers, then throw the exception. And we can take this even further because, as you can see, the possible multiple enumeration is a warning. So if I to list this here, this goes away because I enumerated once. And again, my tests are passing. Please take a look down below. You're gonna find 4 more cases to complete this kata. Watch this video as many times as you want to make sure you understand the process. It's a continuous circle that goes from write a failing test, make the test pass with a minimum amount of code necessary, refactor that code, and go on and on and on into a circle. I can guarantee you that you'll be feeling liberated by the fact that you'll be able to change code without fearing that it might break. This is a very strong tool, and I highly suggest you understand and look into it and start using it today. That's all I had for you for today. Leave a like if you like this video, subscribe for more content like this, and ring the bell as well. and I'll see you in the next video. Keep coding.